Okay, this is 6-3. So this is tests for parallelograms. And we started yesterday talking a little bit about parallelograms. Today we're going to talk a little more about parallelograms. A parallelogram has each pair of sides parallel. Remember that from yesterday? Parallel. Okay, so two sides parallel, two sides parallel. Here are the conditions of a parallelogram. So a quadrilateral is a parallelogram if both pairs of opposite sides are congruent. So let's see if we can draw a parallelogram. And congruent means this side is equal to this side. And this side is congruent to this side. So they're the same. They have to be able to stay parallel. If you think about it, if this side was short and this side was longer, then those two sides would no longer be parallel. So they have to be congruent to keep both sides parallel. All right, both pairs of opposite angles are congruent. So this angle is congruent to the one on the opposite side. And this angle is congruent to this one on the opposite side. Okay? The diagonals bisect each other. This should sound kind of familiar, right? We went over this in the last section. The diagonals bisect each other. So if I draw the diagonal and the other diagonal, then we've exactly cut those two lines in half. So this little piece is congruent to this piece, and this piece will be congruent to this piece. So they are, by drawing both of them, you're cutting each one of them exactly in half. And then this one's different. We didn't talk about this one already. One pair of opposite sides is both parallel and congruent. So if you know you've got a quadrilateral and one pair of opposite sides, could be either, but I'm going to pick the top and the bottom, are congruent and parallel. That's enough to say, yep, that's a parallelogram. So all these things, it's like we're doing backwards what we talked about yesterday. If we have a quadrilateral and each pair of opposite sides is parallel, then you have a parallelogram. If you have a quadrilateral and each pair of opposite sides are congruent, then you have a parallelogram. If you have a quadrilateral and the opposite angles are congruent, then it's a parallelogram. The diagonals bisect each other. That's a parallelogram. So those are just the reverse or the converse of what we talked about before. This one's a little different. If you have a quadrilateral and one pair of opposite sides is parallel and congruent, then you have a parallelogram. So those are the ways you can tell if your quadrilateral is a parallelogram. So let's look. Determine whether the quadrilateral is a parallelogram. So it has to fit one of those rules that we just wrote at the top of the page. And this one shows us that these diagonals are exactly cut in half, aren't they? This half is congruent to this half, and this half is congruent to this half. That was this rule right here. That means, yes, it is a parallelogram, and it says justify. So we'll say the diagonals bisect each other. Okay, so you really just need to use the rule or the words that we put in that little box. That is our justification. It fit that rule right there. Let's do one more together. This one shows us two sides that are parallel. Okay, if we look back up at the top, it says each pair of opposite sides is parallel. So really, if it can't tell us that these sides are also parallel, then they didn't give us enough information. We can't be sure that these are, that this quadrilateral is a parallelogram. So we'll say no. Only one set of sides is parallel. Okay, and the reason that doesn't work, if you like to think about things, this line, although it looks like it could be parallel, what if it was actually drawn more like that? Then these two lines would still be parallel, but these two definitely are not parallel. So unless they tell us for sure that we've got both sets parallel, we can't make that assumption. All right, I got 2 for you to try. Take a minute, pause your video, and then come back. All right, did you say this one looks good? We would say yes. And that is because these lines are parallel, they're opposite, and these lines are parallel. So both pairs, both pairs of opposite sides are congruent. And that was, I'm going to slide my paper, that's this rule right here. Both pairs, not just one pair, both pairs of opposite sides are congruent. Okay, so we got that one. And for this one, we see that this one pair of opposite sides is parallel. That's what those little arrowheads mean. And they're both 3 long. That works, doesn't it? So yes, that's our rule right here. One pair of opposite sides is both parallel and congruent. So one pair of opposite sides is both parallel and congruent. Okay, so we've practiced a little bit identifying quadrilaterals that qualify as parallelograms. Let's turn this paper over and use some of what we know here. Let's see, example 3. Find x and y so that the quadrilateral is a parallelogram. So we want to force these to be parallelograms, which means opposite sides need to be congruent and opposite angles need to be congruent, and our diagonals need to be bisected. So we're going to make that happen by setting them equal to each other. Let's look at this first one. So for this to be a parallelogram, these sides have to be congruent and these sides have to be congruent. And they asked us to find x and y. So that actually works out really well, because if we set up this equation, there's only one variable in there. So let's do him first. 2x minus 2 is equal to 12. Those are the opposite sides. And then we'll just go through and we'll solve that for x. So add 2. A little bit of dividing. And we have x equals 7. 1 done. Let's try to solve the y side then. These opposite sides, so this is where we find our y. 2y is equal to 8. And we can divide by 2. 1y is equal to 4. We did it. So if x is 7 and y is 4, then that means that opposite sides are congruent and this is a parallelogram. We did it. All right, let's try this next one. Opposite angles are congruent for a parallelogram. So let's take, if we do 55 and 11x, they're opposite angles. They should be congruent if this is a parallelogram. Okay, and we can divide. X equals 5. All right, I'm gonna put a little squiggle here because I'm getting them confused. Okay, now the other angle though, so he's not opposite anything. Do you remember a rule from last section 6.2 that might help us with an angle like that? I'm thinking it's consecutive Remember that one? Two consecutive angles in a parallelogram, when you add their measures together, they equal 180, right? So we can say 5y plus 55 equals 180. That was on yesterday's paper. Two consecutive angles in a parallelogram, when you add them together, their sum is 180. So let's do that. And then we just have the y, so we can solve for y. 125. We'll do some dividing. Y equals 25. Okay, so if x is 5, y is 25, then we have made it so that these opposite angles are congruent, and consecutive angles are supplementary, and that means this is a parallelogram. So there's a couple little rules there that will help with solving these. All right, I've got 3 for you to try. Pause your video, take a few minutes, work on those, and then come back and we'll check. Okay, first one, we've got diagonals. So if it's a parallelogram, then the diagonals are bisected by one another. That means this piece and this piece have to be equal to each other if this is a parallelogram. So we'll say 20 has to equal y plus 7. And the other diagonal also. Those pieces have to be equal to each other if this is a parallelogram. Now I'm noticing this has an x and a y in it, so we don't want to start with that. We don't want to pick one that has 2 variables. Always pick the one that has just 1 variable, and you can solve that first. We'll subtract, so 13 equals y. Once you know that, you plug it into the other equation for y. So now 16 equals x plus 13. And then we can solve for x also. So there's that process there. 3 equals x. Did you get 3 and 13? Woohoo! Okay, if those 2 numbers are plugged in, if we pick 13 for y and 3 for x, then those 2 diagonals bisect each other, and this is a parallelogram. All right, so you got one with opposite angles also. Did you do 5y is equal to 25? Very good. Divide by 5. So y equals 5. And then we'll have to set up some consecutive ones that are supplementary to solve for x. So 5x plus 25 equals 180. And let's solve that one. 5x equals 155. Rule dividing. And x equals 31. 31 degrees. Okay, good. Let's do the last one. Doing great. Opposite sides have to be congruent for this to be a parallelogram. So 15 is equal to 6x plus 3. And 2 is equal to 4x minus 2y. I'm noticing that has x and y in it, so I'm not going to start with that one. This is 12 equals 6x. And x equals 2. Now I know that. Put him up here. 4 times 2 minus 2y. So now we have an equation with just y, no other variable. 2 equals 8 minus 2y. Subtract 8. Negative 6 equals negative 2y. And I'm going to divide by negative 2 because I want to know what y is, not negative y. And y is equal to negative 6 divided by negative 2 is positive 3. Okay. All right. You want to go ahead and get started on the assignment 6.3. And next time in class, we'll look at 6.2 and 6.3 together. We'll go over those answers. We'll see you then.